Right guys, scooter time. 5,600 watts of scooter. Goes by a few names. Came in off a customer with a reported hall sensor issue. So I was looking at replacing 3 at the front motor, 3 at the rear motor. Customer disconnected the rear motor themselves because it wouldn't work and only the front was working. I suppose that makes sense. And then the front stopped working, so no motors. That was what I was reporting when we was in the chat. When it came in, I had to pop the lid in front of the customer. That's as far as I got. I suppose the whole point of these videos is to diagnose from beginning to the end and then them rolling out the door. So what I did do is just pop the lid in front of the customer because I like to check everything's there, i.e. battery controllers, etc. It did turn on, the lights do work. What else about it? When you went to pull the throttle, there's a whining coming from the front motor, nothing at all from the rear, but that makes sense because it was disconnected from the controller, so no problems there. I popped the lid to have a look inside. We're going to talk safety when it comes to these big scooters. Anything over 1,000 watts really. Yeah, this one's more about safety, to be honest. So this is the scooter. Let me see. It goes by a few names. Bodega. Let's have a look. HWWH. There's many different names. It's basically the same frame. A company just puts them together, brands of their own. So I've found a like for like, which would be this. 60 volts, 33 amp hour battery, 5,600 watts. Nice scooter, solid frame. Only downsides is the front folding mechanism. I'm not a big fan of that. This handle top section, where there's a quick release, that's supposed to grip, that always goes. I always recommend sticking a bolt in there because of the speed of this scooter. Apart from that, it's a good solid frame. That's what we've got in front of us. Safety time. In all of these scooters, the standard way to connect up these phase cables are these 3-way junction blocks. Now, originally they're supposed to be made out of ceramic, obviously for heat reasons. When you buy the kits for e-bikes and things like that off eBay, they come with plastic blocks. I don't like them, in all fairness. First thing I do whenever I see one of them is cut it out and manually join the wire up, solder it, braze it, whatever you want to call it. There's a reason I do that. One is there's too many failure points between connecting your phase wires to this block to the next phase wire. One point of contention is the tightness, how taut you've got the nut down when it's connecting each phase. I'll show you this close up now in a minute. Another point is the crimp crimped properly onto the phase cable? The hoop crimp before placed on there, that's another point of failure. It's just too much to go wrong with these. And from repairs I've been doing for the past 3-4 years now, not one has rolled in without damage and burnt cables due to these. That's just the way it is. So safety, what I recommend is always once a month, every 30 days, at least pop the lid, have a look at all your wires, make sure nothing's black, nothing's burnt, nothing smells funny, especially when you start talking about these big scooters. So this is the scooter. We're going to take it from the beginning. I did pop the lid and disconnect the battery. I do with everything that comes in just for safety reasons. Sometimes they come in and they could turn on by themselves, take off on, well, just take off basically. I've had that in the past. So I always disconnect the batteries on everything, especially when there's a question mark on it. Now, it come in, like I said, for the 3-phase change, 3-hole sensor changes on front and rear motor. What I did notice when it came in is the rear motor was magnetically locked. What I mean by that is when you try to rotate the motor, you can feel resistance, click, click, click as you go around. That's the magnets locking against the phases. Basically, that tells me if the phase wires were still connected up to the controller. In this case, they're not. That tells me instantly the MOSFETs on that controller are gone. There's a short, and that's what I would do then to confirm that is disconnect the motor from the controller, and if this motor starts spinning freely again with no lockup, then the controller MOSFETs are at fault. In this case, the customer said they disconnected it, and they have. I've had to look inside, 5-minute glance. And what I seen was, well, is horrendous. So this is what we talk about when we come to safety. As for the front motor, I did pull the throttle. There is a whining coming from the front, but it feels like there's a rotation happening, but the wheel's not rotating. It feels like something's rotating inside. It might just be a feeling, and it's not actually that. But for some reason, I think the keyway, I'll show you what the keyway is, that connects the motor to the spindle. I think the keyway might have sheared off because something's trying to rotate in there. So anyway, we'll get to that. Let me just make some space a second. I've had to change the camera because trying to get this in shot on a workbench ain't happening, as you can imagine. But with the power of zoom, we should be able to at least have a good look at it. Soldering irons on standby. Right. So I've literally got this far and disconnected the battery. Right, so first appearances, let's have a quick look. This has been in and out of more times than a revolving door. The wiring is not standard. There's a few rust spots on the heads of the screws, nothing major. These are the things I look at when I'm diagnosing the issue of a scooter. It's not so much one problem, it's looking over the whole thing. So we know the motors are not working, but the LCD up top turns on, so the controllers must be functioning in some manner. So that's a good start. Battery's good, still sealed. First indicator would be the rear motor phase cables. Let's get to them first. Let's pull them out. They have been disconnected. And I might get a bit of white paper. They are completely burnt through. Let me zoom in. What's been happening when they got disconnected? I should imagine they was twisted together, and when the scooter's been functioning, the rear motor has been acting as basically sort of a generator and generating its own current when it's being dragged along. Hence, these are all burnt through. Let me see if I can zoom in a second. Where is the zoom? And it is literally on fire over here. It stinks, the wires. So, these are your phase wires. As you can see, they're burnt. They've stayed in contact with the back of the battery and started to burn through the exterior. Now I know supposedly the sheathing on these cables don't melt till it gets past 220. So we know it got really hot inside. Luckily enough, the fiberglass that's lining the inside of the battery before it got sealed hasn't burned through. Otherwise this would have just gone nuclear. No exaggeration. So first thing we'll do, as we can all see that in a second, what we're going to do is untangle all this, see if the motor starts to rotate freely. If it does, then good news is we haven't burnt any of the phases inside the motor, hopefully. And we've still got something we can work with back there. These connection blocks I just showed you. The problem didn't start here. This block has melted through, is nowhere near where this was. It was tucked on the side. This is melted in the first place. We're going to have a look inside this while we're here, actually. So yeah, these are the sort of things, you don't have to take things apart, but visually inspect once a month at least. As you can see, these are the blocks they ship with that are, well, not supposed to melt. That's gone, so we won't be using that block ever again. Which controller is this connected to? It's connected to this controller, which should be marked A. We'll check in a second. Let's just clean this up a minute. Let's find a good place in the wire and remove this. 1, 2, and 3. Right, let's get that out. So that's the burn section removed. We're left with at least something clean that we can work with a minute. The wire's not damaged no further than that. Let me just clean it up a bit more. Let me zoom back out a second. While I clean all this stuff up. Let me work with my left hand. It might be a bit better. Yeah, you can see better. Right, so let's clean this crap out. Right, we've got something That's at least 3. Let's try the back motor. Right, now she spins nice. Can I get that in shot? No. Great. But that motor is now spinning nice and free by hand. Yeah, perfect. So the back motor seems to be okay a second. Let's just have a quick look at the Hall sensors. This scooter uses Hall sensor filters, I think, in this, or do they switch the Hall sensors round via circuitry? No, it's filters. I took one of these apart before. This is melted through as well. It's actually melted the PVC block. That was the phase cables that melted that. This looks intact there, so I'll call that motor okay for now a minute. That's that out of the way. This connection block, that just bothers me. That's coming out. It's no good having that in there. Alright, so we'll take that out. Alright, we're not going to be using that again. So that's that out and that out. What else we got going on back here? The wiring's a bit of a mess, but I think we can sort out. That's nice and easy. Power, let's separate some of this rubbish. Alright, let's deal with this one controller. Get all this out. That's not going back in. Hey, it's another one of our blocks. What's this one saying? Melted again, through and through. So the sheathing is completely melted through here. That's not tape. I'll bring that up. The other side, controller side of things, is fine, but that block is gone the same route. So let me just cut that back to somewhere where it's good. Basically, I'm just removing all the nastiness first. This wire's been melted through. It's almost broke the core, but that's okay, it looks, for the moment. If it needs replacing, we obviously just cut that out as well. We'll swap that. Oh, there's something going on down here. Hold on. Let's get this block out. We won't be needing that. Let's open up this block a second, just to see the situation inside. It's actually melted together, so I'm going to have to cut it. Crunchy. What we got inside this one? As you can see, there you go. That is not tape, that's just melted straight through. And this block is not as bad as the other one, but still, it's toast, it's burnt. So there's another one out. We don't want to mess with that one ever again. Now, how does the front motor feel? Spinning freely. What I'm going to do is try and lock the motor up a second, just by joining the phases together, and that'll tell me at least if the coil inside is fine. So we'll go 1, 2, and 3. We've also got a serious melt issue down there as well. We'll get to that now. I didn't spot that originally, but like I said, I didn't really take it out. So let me just hold these together a second, all the phase wires. Front motor is locked. Okay, well, that's a good sign. So that motor, phase wire wise, should be fine. Just the Hall sensors. So that's cool. It's looking better. What the hell's going on down here? We got a melt fest again. What is going on here? What is this? What is this? This is awful. This is completely shot through. Let me zoom in on this a second. Where am I? There I am. This whole bunch of wiring is completely shot. The phases have melted this. This is some sort of lighting ignition wire. The only thing I don't like about this is that voltage and the ground are connected together. So that's not going to be fun. So that we're removing as well in a second. Yep. That's coming out. Let me just separate these cleanly a second. If it can be done. Let me zoom back out. Right, the batteries are disconnected, so I'm not worried about that. I would like to know what this wire's for, though. I'll find out in a second, I suppose. I'm just trying to free it up from inside the actual, oh, that wire's gone. Right, that's completely gone. It's burned through. So that's going to need reconnecting and redoing. Switching wire, it must be. Must be some sort of switching wire for something up there. We'll find out in a minute. I'm going to have to keep on cutting this back though till I get some good out of it. Good news is there's plenty of extra cable inside here. Anything, yeah? Maybe. My hands absolutely stink. They're burned. Let's cut that out. Can these be separated now? I think these are completely melted together throughout the whole thing. Maybe? Yeah. How much cable is there? Plenty. So best thing to do would be to cut all of that out. Cut a good chunk of that off. That's burned through. See if there's any goodness up here. And same way. Just literally fuse together the wire all the way up. So this has been grounded at some point. Jeez. Yep. How much have I got left to play with? Another chunk. Hopefully it's fine past here. Otherwise, I'm gonna have to chase the whole cable throughout the whole loom and replace the whole thing. That's a situation. Right, I don't think any cores are touching there. So I'll take that a second as a win. That red's completely shot. And there's the black for there, it's completely shot. Right, we'll leave them. Let me see, let's make it a bit safer. That's burned through anyway. This negative's also burned through, so that can go out. Right, I'm a bit happier. What else is inside this thing? So far, there's a lot of bad being cut out. That's the point. Anything else burnt down here? No. No, no, and no. Right, that's most of the bad that I can see cut out a second. So now I'm going to start joining some stuff back up just to get this to work. I'll see where the controllers and motors at. Give them a test. I'll show how to tell if the controller is actually functioning or not, if it's turning on or not. These are an hell of a mess though. Although there's no rust around them. 60 volt, 51 volt low voltage cut off, 45 amp output, give or take 1 amp. EBS. Now the interesting part is, I know these controllers from experience. These are marked with a model LCD they're supposed to be fitted with. I've got a set of these in the back. They're supposed to be fitted with a QSS4 display. They're marked on the sticker, QSS4. And these are marked LH Chinese symbols. But the point is, from experience, I know that display is probably the LH01 they're supposed to be mounted on, or maybe the LH100, which is the clone of the TF100. Yeah, that took a long time to learn all that stuff. But anyway, we'll get these turned on and we'll see what's what. Warm the soldering iron up a second. Let me just strip the ends off these. Maybe I'm going to do a video live one day. And then if there's any questions or if you've got any problems, I pretty much could diagnose it in chat. Most of the time. Right, so they're clean and clear. there, clean and clear, ready for connecting. Dun. We got here controller phases. Let's also try and neaten this up as well, because this is a bird's nest. I hate it. So we will neaten this up too as we go along, and then at the end sort of cable manage the whole thing, because how they do it out of factory is awful. So there's our phases from our controller. Out the way, you. I'm going to strip the ends off them, and then we're just going to tin everything, put some heat wrap on, double heat wrap as it goes, and connect these up. Do the same for the front. We're not going to use these blocks, again, obvious reasons. Even if they was all crimped up with the hoops, connectors ready to go on, still wouldn't use them, cut them off straight away. It's just one of them things, never would. What we got over here? I suppose for serviceability, yeah, it's easier to change a motor, etc. But I suppose in a factory it's easy to assemble as well. But then you're still going through the time of crimping them in a factory, so why not just hard solder them? Don't know. Maybe it's more labor intensive, I don't know. But if you've got a high powered scooter, you want to get inside and check your connectors. That's the bottom line. So we go 1, 2, and 3. Let's get rid of that power connector and hide it. I'm going to chuck something down to make this a bit more clearer, because right now it's just a bunch of wires and it's a bit difficult to see what's going on. So maybe if I hide all this with that, it's easier. Yeah, that's much more sense. Right, let's go for the front motor first then, shall we? Let me disconnect the Hall sensors for it. Alright, lay that back down. Right, it's easier to see. That's what we've cut out from our connector. Now we've cleaned up the ends. What we're going to do is tin them with a soldering iron first. Put some heat shrink on it. Heat shrink after we've tinned them, otherwise you're going to heat shrink the thing straight on. That's always fun. Little learning caveat there. Let's clean up the soldering iron. Solder, I suppose we could talk solder while I'm tapping these on, because that's done my head in plenty of times. The more lead you can get in your solder, the easier it is to melt. I would say that. And it's much easier to work with, especially on big phase cables. Or when you're rebuilding the tracks on the back of the controllers, which I do a lot of as well. Or big batteries when you're building them. And especially when you use, what, 12 gauge? That wire's a nightmare. Alright, so that's them tinned. I'll go ahead and tin the front motor wires. These phase cables get extremely hot when you're soldering them. So you got to be brave to hold the cables if you're going to do it that way. Otherwise you can make a jig to hold the cables together. Stick a glove on. But yeah, holding these and soldering them is not for the faint-hearted. So that's that. Let's get some heat wrap. What are we going with? What colour? Blue to big. Red. Red. Perfect. Let's get a couple of red out. What heat shrink am I using? 2-to-1 ratio. I prefer 3-to-1. I did order 3-to-1, but they sent 2-to-1. The difference is you get a bit more working room. So if you do heat up the cable and it starts to shrink, 3-to-1 is going to last you a bit longer before it closes up on you. And you can really stack it on top of each other as well, if you want to put layer on layer of heat wrap. So we'll put 2 on each cable, because I'm going to put the first one across when I've soldered it, warm it up, pull the second one across. You know what, I probably should have gone bigger. I'll try it. Last words, I should have gone bigger, I know that now, but we've cut it. Never mind. Reason is when we join these two wires together, sometimes you get a well, a bit of a big bulge. The point is, you want a nice clean shiny joint, no sharp edges, double layer it with insulation, triple layer if you want to, quadruple layer. Go nuts. But the point is to keep it nice and clean and smooth. And it's better than that block. Put it that way. Let's make this wire a bit more accessible as well. Right. Set yourself up nice, and then it'll be nice and easy. Right, what I'm going to do is heat the one up I am not holding first. Because if you heat the one up you're holding first, it's going to burn your fingers by the time you get to the soldering iron up to that one as well. Why does this feel awfully short? I didn't even cut anything off it really. Ah, it's all cable tied in. 2 seconds. There you go. That's better. Dun, dun. Right, that'll do. Set yourself up ready. What you don't want to be doing is trying to squeeze them together and do all this and that. Set yourself up first. Then I'm going to heat up the one I am not holding till it goes all flowed. Stay still for a few seconds. Job's a good one. There's a little edge there I don't like. There you go. Nothing sharp. Pull the first one across. Did I get away with this heat shrink, or should I have gone bigger? I should have gone bigger. I did say. Right there. I knew I should have gone bigger. Lesson learned for the back one. We'll go bigger. There you go. We'll heat that up in a second. Pull the second one across. Let's do the blue next. Should have really checked the orientation. Sometimes on the phases they switch the blue and the green around the opposite way, and what that does is spin the rotation of the motor the opposite way. But then you've also got to adjust the holes to match that up, but that's a whole different topic. That can be fun though. One day maybe. Heat the one up I'm not holding first. Then bring the other one onto it. That's that one. What's going on here? Oh, I can't see properly. Hold on a minute. Because I'm sitting lower than the thing I'm soldering. That's not good. Let me unsolder that, retin it and do it again, because I'm not happy with that. That's better. There's a tip, who knew? Make sure you can see while you're soldering. Just using the force on that one. Right, let that cool down. We'll pull a heat wrap over that one. And then we got a green left. And then I think we're going to turn it on and see what's happening. Because it did power up. The rear controller is supposed to be the main. Supposed to be. Let's get this heat wrap on a second. There you go, we heat that up in a second as well. Green one left. And that's that. I am going to be fast forwarding in some of this, I hope. Goes a lot better when you're looking at what you're soldering though. Right, that one's done. Pull this over nice and quick. Done, heat that one up in a second. In fact, let me grab something quick. I don't want to put the hot iron on at this point, so I'll just go like that. like that, and like that. Start putting the other layers on as well. That. Right, I'll do a second. Let's remove the mat. Where are the holes? Holes for this controller are there. Plug that back in. Right, front motor situation addressed. This we'll get around to in a second. Rear motors next. Turning on after that. Okay, here we go. Where are we to? We're over here next. So, if I place this, my power connector's doing my head in. Let's hide all that mess. Right, same routine again. We've got the rear motor cables. Green, yellow, blue. Same over here. I learned from last time, go one size bigger on the heat wrap. No problem. What is one size bigger? We'll go with this one. Alright, so we go up a size on that. Let's tin these up ready. What I'll do is I'll fast forward this. I'll tin these up, connect these back together, and then we'll get back to turning it on. I think that'll be the best thing, because watching me do this is like watching paint dry. So bear with me a second. So, rear motor then. So, front motor, fresh, cut out, all the crap removed, resoldered. Same with the rear motor. So what does that tell us? First of all, everything's burned out, everything's removed. Now, the rear motor's connected to the controller. Obviously, just wired up the phases. Now, I want to know if I can free spin this rear motor again. If I can, then I know the MOSFETs are at least in some way okay inside this controller, as in they're not shorted with each other, the phases inside the actual controller itself. If they are, we'll get to that. I'll open the controller up and show you that. But that freewheels. So that tells me inside that controller something is at least good, and I know it turns on. So at least we've got an up, down, 48 volt, 60 volt return. That's good so far. Let's check the front motor. There's the front motor wiring. Let's just rotate that. Free spinning. That's another really good sign. So I like that. We're going to ignore this mess a second. Get that mess down there actually. So next, we're going to introduce some power next, because everything's been cut out that was damaged that I can visibly see. So now I'm happy enough to go ahead and put some power into it. Let's connect up the phase cables for the, the hall sensor cables for the rear motor. That would be them to there. Okay, obviously the filters are still in line. Filters, not sure. I have cut one of these open. I keep going back to them. It'd be nice if they were fuses, because if ever the phase cables actually shorted one of the hall lines, the green, blue and yellow, and these were fused, it'd stop sending anything more than 10 volts back into the controller, blowing out the line. This is a good idea if these are fuses. If they aren't, then I'm making them. If they are, then I need to know where to buy them. But I'm thinking of making these boards and putting fuses in, because the amount of repairs I've got to do and swap controllers out that are perfectly good, except, well, the voltage regulator goes, and I can swap that out easy enough. But then, at what point do we buy a new controller when they're only like 40, 50 quid? If I got to sit down for an hour diagnosing the issue on the PCB inside there and swapping out parts, it's the same price. May as well have a new controller, unless we're beefing it up and swapping the capacitors out and chunking up the MOSFETs, rails, etc. Otherwise, it's not worth the repair there. So all that's cut out, that's good. All that's a bird's nest, ignore it. It's all about these motors a second. So let's plug the power in. There's going to be that spark. Some people get scared when they see the spark when you connect up a controller, when it's been unplugged for a while. What it is the capacitor taking load. It's just drawing basically current from the battery, amps. So you will get a spark. Hopefully it's a good spark. Here we go. Cool. Happy with that. Second one. Whew. That one hasn't been connected for a while. This, I think, is the switching for the indicators and all that. Right, just by the off chance in case it starts going. Motors are free to spin. Let's stand up. I've gone and hemmed myself in here. 2 seconds. That was a bad call. Disconnect that. The wrist is still playing up, so that hurts. Anyway, at least now when I get to power through these controllers, I can do other tests. I can show you other tests. We can test these Hall sensors. We can test the controllers without having to open them up, just by testing the Hall sensor lines. Whether the voltage is being dropped down from 60 to 5 to feed the sensors. That tells me a lot as well. Let's get some power. Right, she is on. Oh, she is on. No errors have come up yet, but I'm suspicious about the screen, if I'm honest. I'm suspicious because I haven't seen this model on this type of scooter before. Right, okay. Rear motor is now flexing, trying to turn, but it is jammed. Let me hit dual drive. Front motor is now starting to rotate and then jamming. That's better than it was last time. Okay, we got something decent to work with here. Things are looking up. Still broke, but in a good way. Broken in a way I like. Put it that way. Nothing is a mystery right now. So good. Hall sensors. Let's check these rears. We can do 2 checks. Check the controller is giving out 5 volts. Nice and simple. Let's turn the multimeter on. Let's roll up the sleeves. We're looking for 5 volts. It says 5 volts in every book you read. It never is 5 volts. It's 4.8. Don't know why they say 5 volts. They even got me saying it. But it is, I've always found it 4.8, never 5. And even if you inject 5 volts, I find it doesn't operate properly. So hopefully this should say 5. 5.4. See what I mean? This is strange. Should never be over 5. It's always 4.8. It's good strange. So let's check some sensors. Let's go for the yellow sensor first. What the sensors do, as you've seen, if you haven't, good opportunity, go back to the sensor replacement video, e-bike, exactly the same as inside these motors. The sensor is going to be turning on and off. It's going to have full voltage, no voltage, full voltage, no voltage, every time it rotates. Do we have anything? Nothing. Good news. At least I know off the bat, the yellow sensor doesn't appear to be working. And the only thing to consider is we're running everything through these filters here, or whatever they are, these mystery items. Someone tell me in the comments if you know exactly what they are. This is the only type of scooter I've seen with them, mind. So we're on to the green hole. Nothing when we rotate it. And now, last one is, get out of there you. The blue, check the multimeter out, 2.2 volts. Nothing. I should be going down to 0.7 and back up again to 4.8 usually. Why am I getting 5.2? It's curious. Let me just check past these filters, because right now I'm checking everything from the controller, then via this through the motor. Let me just go direct a second. Unless they're smooth, yeah, well, I don't know. Smoothers maybe? Might be a filter, the same thing. So let me just check. Where's our voltage? Where's our voltage? This connector is melted. Hold on. We have no volts past this block. Oh, this gets better. So past this filter block is no volts at all. Let me just check before it and make sure the scooter hasn't turned itself off on a timeout. Bear with me. Just do this quickly. Scooter's turned itself off, haven't it? Have you? No, you haven't. Ooh. So if I check this side, I'm getting my 5. If I check past this filter block, Not getting my 5. Cut that out then. Let's get this filter out the way a minute. That's clearly blown. Are they fuses? And it's done exactly what I said it's supposed to do. So they invented them before I could think of them. Great. Now what's happening? I'm going to have to check these holes all over again. But that filter is now gone. Am I getting voltage? Yes. Yellow sensor. Can't remember what the reading was last time, but it doesn't really matter. Oh, it's 2 point something on here. Is that enough of a difference? Maybe it is. Usually it's a big swing in voltage, a good 3 volts. Let me just try the green a second. 2.1. Nothing, so green, yeah, okay. Sensors are gone, that's fine. That's happy. But at least voltage is running through there now. Back motor still shuddering. So okay, Hall sensors I'm thinking back there. That's cool. Let's check this front motor out a minute. The controller is turned on definitely because it does try to rotate. So again, should be getting our 5 volts, or in this special scooter's case, 5.2. We have nothing. Nothing at all. Let's disconnect this sensor block. Is there one on this one? Yeah. Okay, good, good. I like this. And that's another fault found. Let's try straight from the controller. Nothing. Let's try again. Nothing. Is this sensor shorted? Let me disconnect it. Right. This is from the controller. Let me check the wire is fine and intact. Yep. Nothing melted. So this controller has no voltage at all. Right, so this controller is supposed to be giving out 5 volts through its Hall line, as this controller did. It is not, which generally means the controller is not turned on or not functioning. She does try to spin, but she's got no sensors, so she can't. I think the voltage rate... Oh, now she has. Right there. I think the switches are burned through. Yep. Okay, that I can fix, which bypassed that a minute. So basically, there's a few things to repair as we're plodding along. But now this controller is turned on. Let's check the holes. What we got? Now this one is reading 3.3. When I rotate the wheel, I get nothing. Oh, wait there, sorry. Yeah, that backfired, didn't it? Let's plug the thing in, shall we? I'm cutting out that as well, because that is not helping the situation. Now these, we're gonna look at one of these in a second, because that one's failed, the other one's failed. Why are they failing? There's our 4.8. See, that's nice voltage coming from the controller. Remember I was saying it's 4.8 is the usual, not 5.3. Well, there we go, 4.8. Yellow sensor is, ooh, working. Here we go. As I rotate the front wheel slowly, we got 0 volts. Sensor just turned on, turned off, turned on, turned off. Cool. So one sensor is at least okay. And that's the yellow. Second sensor's up. As I rotate. Ooh, second sensor's cool. And last sensor is the blue. If that works, this motor should work in a second. Right there. This sensor's going absolutely ape. Yeah, something up yet. Well, that's okay. Don't mind one. Oh, wait there. I think it's just the wiring I need to address on that one. Nah, sensor's shot. That's okay. So we got blue sensor on the front, 3 on the rear to swap out. That's the next job, and then we can go from there. Okay, that's not too bad. Let me just run through the problems. So that's that. What we're going to do is remove a motor. First one we're going to pick on is the rear. We're going to do the rear. We'll do the rear motor first. Yeah, this video is going into parts. So call that part 1. Part 2, rear motor, strip apart, 3 sensors dropped in. Happy days, back on the back. Gonna address these wires and stuff, but we're back on track now at least. I'm happy with the controllers. Yeah, sweet. Right, catch you in the next video, guys, and we'll be doing a motor teardown. I may as well whip the 2 motors off. I'll do a few sensors, fast forward through the rest. We'll get back onto mounting them. She should roll from there, and then we just got a load of mess to clean up, including now one wiring loom that's completely melted through. I don't see this not working though. Right, leave it there. Catch you in a bit.